Hey everyone, today we'll be taking a look at 1678 Citrus Circuits' 2024 robot for the Crescendo FRC game. This robot was extremely successful. It was highest ranked in the world based on EPA and was the winner of the Archimedes division at Worlds and made it to Einstein's for the 10th year in a row. And I think it does a lot of things really well. It's when we take a look at it, you realize that it's really not that complicated of a robot. And I think what Citrus does really well with this design is to keep things relatively simple and just have an overall very robust design that I think attributes to their incredible success in the 2024 season. Okay, so here we are with the CAD for 1678 Citrus Circuits 2024 robot called Epsilon. You can see just by looking at it all the different subsystems that we'll be covering, from the basic stuff like the drivetrain to the more complicated things like their shooter or their amp mechanism. We also have the indexer here, and then the intake and the climber. Yeah, starting out with the most basic of things, we have our drivetrain. This is probably the most standard part of the robot, but what they're using here, they have a 26 by 26 frame perimeter. The swerve pods they're using are Mark IV-I swerve pods from SDS, which is a pretty common swerve pod, especially in 2024. Here for their battery, how they secure the battery, they use what looks like blocks here that have these are clevis pins, which basically allow for easy detach and reattachment of this plate, which covers the battery. Here you have your Robo Rio, your PDH stuff that every team would have, and your Pigeon IMU, and then your Anderson connector and breaker. You can see here these box tubes. These are used to kind of box in the battery here. What other teams would sometimes do is some teams would use box tubes running across the drivetrain, just kind of have mounting points for other subsystems on the robot. Citrus doesn't really do that here. These are just kind of structural pieces just for the drivetrain and to house the battery. They don't really attach to other parts on the robot for mounting. Yeah, so that's about it for the drivetrain, pretty standard. And so next we'll be looking here at the intake. So this is the part of the robot that comes into contact with the notes first, and is really what pulls the notes and feeds it into the robot to score later. So you can see this isn't really a 4-bar or anything fancy like that. This is really just a pivot intake or a slap down intake. So you can see there's a shaft here that's powered, and then that has a chain to a sprocket here, and that just pivots this down. So before the match starts, this would start upwards to be in frame perimeter like it is now, but once the match begins, this can drop down, and then it can start pulling in notes. So you see here we have 2 polycard rollers on the front. We have one on the bottom, one on the top. The one on the bottom kind of kicks the note up, and then this one kind of grips the top and pushes it in. And this spans the entire width of the bumper, which gives a big range for where to pick up notes. And overall, this is a very simple design, very reliable, which attributes to Citrus's success this year and reliability with scoring. Hence how they made it to Einstein's and such. But here you can see the note, once it pulls through these polycarb rollers, it hits these 3D printed parts. Those kind of funnel it up into the the indexer. And we have another polycarb roller at the top, and one here for extra control and also to change the angle, because when we're feeding into the indexer, it needs to kind of bend downward a bit in order to be able to be fed correctly. Yeah, and then you can see here we have our belts. These power the rollers for a motor here, that's just belt off. And then this is geared down here, and then this also has a gear here that connects to this belt, which is how this belt right here, which is how these ones get powered. Yeah, so overall is not a super complicated design, which is good for consistency, reliability, things like that. Also, just from the design phase, it's very easy to prototype. Yeah, so just kind of just kept it simple with this intake here. All right, so next that moves now into the indexer, which we'll take a look at here. This is interesting because it doesn't really attach. Like I said before, it doesn't directly bolt down to any like drive rail across the drivetrain. Instead, it has this kind of cutout here, which links it around a shaft. You can see it's this shaft right here that goes through here, so that shaft is shared with the pivot joint of the shooter. So that kind of goes from this plate to opposite plate, which is over here, and then it just kind of has that cutout in the plate, and it just kind of sits around there. So that would be free to rotate, but then it also sits on the top of this forward pod here, so that just kind of fixes it in place, sort of. But yeah, so once the note goes through the intake, it is fed through this gap here between or underneath this set of rollers. So this just pushes it through with motor powering this roller. This is just roll, and then it just pushes the note through. Next you have this roller here, which is for extra note control, and then that feeds it to this area. This kind of like the staging area, which I think is kind of unique, because how they do it is that they have a separate place for that the note goes when they want to score in the amp, and also another one when they want to score when they want to put it in the shooter to score in the speaker. But basically, depending on where they want the note to go, it's either going to go through these two rollers into the shooter, or it can be fed upwards using this roller, which I'll show you in a sec, in the front right here. Get this polycarb roller in between that one to pull it up into the amp. So you can see the amp here, or the amp mechanism here. This is on an elevator, so this is a one-stage elevator. You can see you have the immobile stage, or the zero stage, and then you have your first stage. So this is a canted elevator to kind of reach up and give the necessary lateral distance to get into the amp. This is what I think is the most unique part of the robot, because it's its kind of own separate mechanism and has its own elevator, and it kind of sits between the intake and the shooter. So raising it up here so it's easier to see, you have a lower polycarb roller here, and then you have one up here, and then three up here. And how it works is that the note basically gets fed upwards, and then using these rollers up here, it goes up. You can see behind this roller, between here, and then it bends up through here, and then goes through these two rollers and bends like that. So it kind of loops around, because since the notes are foam, they're just foam rings. Citrus is kind of utilizing that bendability of the notes to a really big degree to be able to bend it completely around, because to score the amp, the note has to basically be going downward. So this kind of helps bend that note around with all these rollers, these 5 rollers, to get the note to the right angle they want. So to get from that position, obviously it goes from the indexer up, gets put into here, this kind of staging area, and then this roller can spin clockwise, and this roller would spin counterclockwise, and that pulls the note up into it, since this roller is already in contact. So that would just push it back, and then this one helps pull it up, and then it gets fed into there. So yeah, I think that's probably the most unique part of this robot, is this whole amp mechanism, which I think is really interesting. All right, so moving on to the next subsystem, the shooter. So if we go ahead and hide the amp mechanism, or the trap mechanism, you can see here the indexer, which I talked about before. The note is kind of staged in here once it's pulled in by the robot by the intake. And here, these two rollers are kind of what are going to feed into the shooter. So this would rotate counterclockwise. I talked about before, when it's fed into the amp mechanism, it spins clockwise along with help of the polycarb roller and the amp mechanism right here. But just looking at these two, this would spin counterclockwise, and this lower roller set would spin clockwise, so that pulls and feeds the note up between these two polycarb plates that are part of the shooter. So if you take a closer look at the shooter here, you'll notice kind of this asymmetric design where all the flywheels are just on one side. Other teams, what you'll probably see is 4 flywheels, but 1 on each side of the shooter, and those could probably be controlled independently. But here, Citrus has gone for just putting them on one side. And what they said about this design is that when they were prototyping, putting flywheels on just one side gave them the necessary stability for the note after it was shot out. And that's because since you're just propelling one side of the note, you're essentially applying a force just on one side of the center of gravity, and that will apply a torque to the note and be able to spin it, which will give it gyroscopic stability. So you can see these are geared up using pulleys after they're powered by each of their own Krakens. And this whole thing, since it needs to be pitched up or down to aim, uses these gears on the side of these plates, and these are powered by a motor. So this part would rotate, and then it would mesh with this gear plate here. So when this rotates, it would mesh here, and we could rotate up and down this whole apparatus here. So then you have the same thing on the other side with this gear is attached to the same shaft and powered by the same motor as the other side. Same thing meshes with here, and it can rotate to pull it up or down to aim the note. All right, next we will be looking at the final mechanism or subsystem of this robot, and that's how this robot climbs the stage and does the trap. So when this robot is preparing to climb up on the chain, if you imagine the chain is kind of hanging in front, the robot will drive forward a bit past the chain, with this side being the front edge. And this part here starts in this upright position and gets pulled down on top of the chain. So how that works is that this is pushed outwards using these two gas shocks here. So these are kind of just like springs, but that use like air. Basically when you press them, the air compresses, and that would want to apply a force outwards, so that it kind of just pushes outwards all the time. And then these when it wants to get pulled in, there are two spools on either side. There's one here, right here, and then one on the other side as well, over here. And these are attached to a common shaft powered by a motor, and there is a cable they don't show it here in the CAD, I don't think, but if you were to watch a video, a cable attached from this climber down to the spool. So when that rotates, it kind of winds that cable in and pulls this down against the gas shock, which is pushing out on it. So when this is up, the winch unspools, and when they want to pull it down, the winch pulls in and spools up the cable. So this gets pulled down, and right here is where the chain gets hooked into. So the chain just goes right into these holes here, or these cutouts in these plates, and that pulls it down using the winch, and it hoists it up. And essentially this front edge is going to be leaning against the stage, or like against where the trap is, so it kind of stabilizes it, or else it would just tip forward. And then to score in the trap, it uses the same exact mechanism for the amp. So like how I said before, the note is loaded in, it goes up into here, and this would extend out, and the note gets bent all the way around, because just like in the amp, the trap needs the note to kind of be shot down into it. So it uses the same kind of note bending layout of the rollers to get the note to go around and down into the trap. So that's the complete overview of 1678 Citrus Circuits 2024 robot for Crescendo. I hope you enjoyed this overview of this robot.